In this lesson, we are going to assemble this smart car, and step by step, everything including wiring and installing this motor driver, all the components, and then simply we'll power it up so the car can move. In the upcoming projects, we will have fun with more advanced features. Welcome to Arduino course by Robojax. This course is based on SunFounder 3-in-1 Arduino kit sold on Amazon. Everything that you learn in this course is included in this kit. The course comes with tons of components and projects, all with instruction and video for smart car and other projects that you can use for school or home automation. You can purchase it from sunfounder.com. The kit also comes with full documentation, code download, learning projects with full explanation, wiring diagram, and the code that you can download. The link to purchase the kit and documentation is below the video in the description. Welcome to Arduino course by Robojax. In this lesson, we are going to learn how to use a smart car. And first, we will start with the assembly of the car. So when you go to the documentation page, under learning project, we have car projects. And so we have move by code, speed, follow the line, play with obstacle, and other projects. First, we are going to do the assembly and assemble all this. After that, we are going to go for the code. So initially, we need all this to start building the car, the main base, this wheel, two wheels, this hardware that they all come with a kit, and then the motor driver, and perhaps in some and this mini breadboard. First, let's get, this is acrylic laser cut. First, let's just peel this protective sheet that is on it. Just get a screwdriver and peel one portion. And the same way we can do for this side. In the same way, we have to remove the protective sheet from all these four pieces. Start the assembly. First, this piece is facing that way, these two notches that you see, and Arduino Uno revision 3 will go on these four holes. As you can see, two holes are close and two are apart. So let's call this A so we do not make mistake. And if I turn this around, I call this B. Now the two holes closer are here and the farther away holes are in there. We are on the side B. We will get this piece and insert them from side A like that. And one more, there is no hole, so you just put it, it will be like this. And this is where we will attach the DC motor in here. When you're attaching motor, pay attention that the wire should be towards inside the car, like this, not the other side. And we have a hole here where you can pass the screw. Now we need this M3x30 and M3 nut with these screws. We will start. So to attach our motor, we insert our screw here at the bottom, so it will be easy later. Then let's insert the second screw. And the two motors have been assembled properly and secured. Now we will use M36 to attach this standoff on this board. We will attach them on side B. On side B, on these 4 holes which are at the middle, and putting the screw from bottom. Now this is ready. We will attach this wheel using the same M36 screws, 4 of them. This wheel stand have been installed now on side B. Now we are attaching the wheels. This is inside and that's outside. We just insert them from that and from this side. Realize that this screw from this side is blocking the motor, so I'm removing it. Now the motors are ready. The screws have been inserted from this side and also from this side, so the tips are inside the car. Now we will insert the wheel. Pay attention, you have to make sure it is in the right and push it, and the same way from this side. We simply just push the wheel that goes in the shaft. Now we will attach this motor driver, and here on these 4 screws, but we will put the standoff so it's up, lift it up, and the screws will come from the bottom. The standoff ready now. Now we can attach the motor driver like this with 4 screws, and it will be installed like that. And here the motor driver have been installed. Now in order to install Arduino on the side A, and here we need to use this M324 standoff. We need to mount this Uno board on the side A, and we need to use these standoffs. We will attach them using this M36 screws from the bottom. Here 4 standoffs have been attached to the side A. Screws are in here, 1, 2, and then 3, 4. And here the Uno board have been attached using these 4 screws. Now we are going to use M310 screw and M3 nut to attach 2 of these infrared obstacle avoidance sensors, one in here and one on the other side. Both of these sensors have been now attached. Now we are going to attach this line tracker using these 2 standoffs at the side B at the bottom. So this will be attached using these 2 and 3x6 screws. And here the line tracker has been installed. And now we are going to attach this Velcro to the on the surface and on the battery, so we can attach the battery and pass the cable from here on side B between these 2 motors. Now the battery is attached and secured. The last thing that we do is attach this small mini breadboard, and here we will peel this off and attach it. Mini breadboard have been attached. Now let's understand the DC motor. The DC motor is a device that if you connect it to a battery from using the 2 wires, it will start rotating. Turn it off, we will have a switch, something like this. To connect and disconnect, the motor will turn off. We can move the switch from positive line to the negative line. Still, we will have the same effect, that we will disconnect it and the current will stop and the motor will stop rotating. Now, if we have the positive on this side, this is just an example, this particular motor will rotate counterclockwise, and the current comes and passes through this, it rotates. Now, if we switch the positive, which was at this terminal, and move it to this terminal, then the motor will rotate in the other direction or clockwise. Now we can create some kind of switch that we can move the switch so the motor will rotate in one direction or in the other direction. This gray is a switch that has 3 pins, and this is another switch that has pins. For example, the positive comes like that, and it is connected via this wire, via this pole of the switch. So the positive comes, and from this pin it enters the motor, and from this side it comes back and continues. So the motor is rotated in one direction. Now if we move the switch up, 2 switches together, now the positive, which before was connecting to this terminal, is now connecting via the switch to this terminal, and the negative goes like that, and the direction of rotation of the motor is changing. So we used a switch to do that. The same way we can put electronic switch or a motor driver that can do that. Now if you connect a DC motor to Arduino, this will not work because Arduino's output cannot supply enough power to the motor. So the amount of power is the product of voltage times current. So this provides very little current. So we need to have a driver between the microcontroller, such as Arduino, and the motor. So this is called the driver. It receives very small signal and amplifies it, and the amount of current is increased, so we can control the motor. Now, DC motors usually will have a back electromotive charge when it is disconnected or connected or turned on and off. So we need to put a diode here between positive and negative to prevent it from damaging this driver or our microcontroller. When it's turned off, the positive. So in this lesson, we are going to use this motor driver L298N. The model is written here. We first explain the module, then I'm going to show you the wiring, and simply will make the car move, nothing else. So this will prove that our wiring is correct, and then we will jump to the other lessons. We are going to use the L298N. You might see it as blue like this, but this is the one that we are using. And also you might see it with different terminals, like yellow terminals. It's exactly the same chip, except the terminals have been moved around. So I'm just showing you so you know that this is exactly the same chip, except with different color or shape. But ours will be this one. And as you can see, we already have diodes built on the module, so we are not worried. It will protect our chip from back EMF of the motor. Now let's have a look at this DC motor module L298N. That's the chip. Everything is together. We call it a module. And the motor that you can connect to this will be maximum 35 volts. So if your motor is 12 volts, then you can connect the power supply of 12 volts. If your motor is 30 volts, then you can connect 30 volts in here. And it can fully control two motors with a power of 2.5 ampere maximum. But for continuous long time operation, if you have this heatsink and it's cooled down properly, you can go maximum of 2 ampere. But for very short periods, you can go up to 3 ampere in few seconds. And this also can supply 5 volts for your Arduino. So it outputs. You connect your whatever voltage you have, let's say 24 volts, 12 volts, and it outputs 5 volts. You can connect it to Arduino as well. This is dual full bridge. And here, this is one half bridge. So this is half bridge, and it has in and enabled. And if you connect the output of this to a motor, the motor side, the other pin is connected to the ground or positive. And then, so you can control this motor only in one direction. You cannot change the direction of rotation. So you have 4 half bridge in this chip. You can control 4 motors if you want to rotate them only in one direction. And if you want to control a motor fully, then you need to use 2 driver, 2 half bridge. So now 2 half bridge is called full bridge. So this is a full bridge that if you pay attention, before one side of the motor was connected to the ground, now we are connecting it to a driver. So this is acting as positive and the other one as a negative. Now let's see if we connect both of these enables together. If you connect it to high, or let's say 5 volts, and then we have in 1, and then for the other one we call it in 2. So we set in 1 to high and in 2 to low. This output will be high to this pin. This pin will receive high, and this pin will be connected to low, and this motor will rotate in one direction. Now let's pay attention. If we change this high to low and low to high, now what happens is this is now high. The pin before, which was high in here, now this is receiving high, or a high voltage, the actual voltage, and this side will receive low, and this now will change the direction of rotation. So we are using 2 half bridge. And this device, if you want to control 2 motors fully, so we have dual full bridge. So this is one full bridge, and this is another full bridge. So we have 2 full bridge in this L298 chip, and we can control 2 motor fully with the speed and direction. And here internal block diagram of L298. These two drivers together, this is called, these two together can be used for one motor, and these two can be used for another motor. So this is half bridge, half bridge. I've written a library for L298N where you can control one DC motor, or you can control two DC motors, or also in that video I will show you how to connect two of the bridges in parallel, so you can get to increase the power, and you can go up to 4 ampere motor. And here for our motor driver, for the one motor we have enable A, if we call this motor A, N1 and 2. So these 3 pins are for one motor, and for motor B, enable B, and N3 and 4 are used for the other motor. So we are using these pins to control our motor. Enable B and enable A are already connected using this jumper, so we are not using them. We just use N1 and 2 and N3 and 4. And here we have a table. Enable is 0, the motor stops, and N1 and 2 doesn't matter. And if we always have it enable 1, we set the jumper, so we don't worry about this line. Now pay attention. If we have N1 and N2, both of them receive 0, the motor will brake. And if both of these are 1, also the motor will brake, so it will stop. Now, if we have N1 0 and N2 1, it will rotate clockwise. And if we switch them between these 1 and 0, make them 0 and 1, and it will rotate in the other direction. That's for A, and the same way for the motor B, which is left. Now motor A is connected to the right of this car, and motor B is connected to the left. So first, the one motor, this is the motor, the wire is coming from this hole. We are connecting the positive on this side, the negative on the other side. For that motor and for this motor, we are connecting it to the same side. Pay attention here, the positive is on this side, negative is on that side, and then we connect the 12 volts to this 5 volts and ground to the ground. Do not worry when it says 12 volts, we are simply just making the motor to rotate. And here let's connect a red wire to this point. Connect the red wire and then the black into the middle one. This is the wires for the motor on this side. I'm gonna connect it. I'm gonna connect the positive in here and the negative on the other side. And for this motor, here is the wires. And let's tighten them. And here the negative goes to the ground, the black, the red goes to 5 volts. So pay attention here, the first and the last will be connected to ground, to the middle terminal. From here, the first on this side and the last will be connected to the middle. I'm going to use this. One side is female, the other side is male. So I'm going to connect it all together, 4 wires. Together, and I'm going to get the last and first together and connect it to the ground, and then tighten it. Now this wire was removed, now I have to insert it. So there we have 3 wires at the middle, and these 2 will go to the last one, which is positive. We have to make sure that this wire also stays. So here now we have 3 wires at the middle and 3 wires in here. And here is a demonstration. We have not done any programming because this is directly connected to positive and 5 volts, and then we are sending the same signal. So this should start moving. This piece is just holding him, and no programming is needed. I can just simply connect this battery that we have. The battery wire is ready. Let me connect it so we will see if the wiring is correct and there is no smoke. So as you can see, this is now rotating, and it is going forward. So the wiring is okay, and our project worked. If we want to change the direction of moving of the car, these 2 pins that are at the middle, we can connect them to the outside and the 2 outside to the in. So pay attention like that. So let me put the 2 that were outside, connect them at the middle wires, and these 2 so I've switched the wires now. Let's just connect it. So this should now move this in this direction. You can see. If you have done up to this point, congratulations. Now we are going to have fun and go with advanced projects. So to turn this off, there is no switch or anything. We simply disconnect the power.